Okay, let's continue with our Encor topics. In this case, we're going to talk about the Encor 1.5 chapter, which is Interpret Wired and Wireless Quality of Service Configuration. In order to understand the information in this chapter, we will need to know the quality of service theory that is included in a different chapter in the Encor syllabus. However, I will try to accommodate some definitions when trying to explain the commands because this is about learning to read configurations. So before moving forward, I set up this table doing a little bit of research. And you might have you might found some errors probably. And the point I want to make here is that the syllabus is not specifying what type of quality of service configuration you need to be able to read. So I have assembled these sessions talking about old configurations and the newer configurations available in Cisco Catalyst switches. Notice that there are a series of Catalyst switches that are not available anymore. For instance, the 2940, the 3550, the 2950, the 2955 that have reached an end of life uh, in the previous decade. And this type of old catalyst switches will use a certain type of queuing mechanism known as weighted route robin. This was not a really good mechanism because it will not serve your queues very fairly under some circumstances. In order to show what circumstances this algorithm becomes not very effective, you will have to set up a very complex example of queues. I'm not going to go into that. I'm just going to explain it at that. Uh, then we had a series of switches, for instance, the 3750, the 3560, 2960, 2970, and so on, that will use a new way of serving queues that was known as shaping and sharing round robin. What that was a little bit better than weighted round robin. The issues come usually when you use priority queuing. When you use the priority queuing, you can reach something that is known as a starvation of queues. So this evolution was good because SRR was better than WRR. This is actually the internal way that the new class of switches serve queues nowadays using SRR and other new types of technologies that have evolved from these old switches. And in the most recent years, the catalyst switches use a full-fledged version of MQC, modular quality of service CLI commands. So the objective of this chart is just to show you how this evolution has happened with quality of service configuration commands in Cisco. So for legacy switches, as a summary, we have MLS, QoS, WRR. This for all switches, you could only work with egress queues. But for certain switches, for instance, the 6500 using a supervisor card 720, you could work with ingress queuing. So the commands will be either MLS QoS receive for working with ingress queues, and then when we had the evolution into sharing and shaping route robin, the commands were MLS QoS SRR, And with these commands, you could work with either ingress queues and egress queues. And then we evolved into the modular QoS config when you will have class maps, policy maps, and service policies. This will help you to work with ingress and egress queues. When I'm talking about ingress and egress queues, I'm talking about the queues that exist in your switch for receiving packets or frames, and for the queues that are used in order to send packets or frames out of your switch. So if you have your switch here, you will have some queues where the frames or packets are stored here and at the input point, and you will have some other queues that are used to store these frames or packets before sending out into the cable. So I'm talking about those queues. That this will be the ingress queues, and this will be the egress queues. So this is the evolution of the Cisco quality of service commands. And recently, there are more options using something that is known as hierarchical QC or HQC, where you can do or you can have a policy map that lives inside another policy map. So you can have a father policy map, so to speak, that can call the way that you call a function, just to make a similarity with programming, another policy map. So you can do complex quality of service things there, such as complex policing with hierarchical QC. This is also available in more recent switches. So this will be the evolution of the commands. And let's talk a bit about wireless quality of service evolution. With old wireless LAN controllers, remember that your wireless LAN controller sits between the wired world and the wireless world. So with old wireless LAN controller, we could only manage the wired world. We could only influence the way that we will set up the DSCCP marking for CAPWAP tunnels, and we had some sort of quality of service for applications using NVAR. Remember that NVAR means network-based application recognition, and it will let you set up a certain level of quality of service for applications rather than for access control list. With NVAR, you can say, I want to provide a little bit more bandwidth to YouTube streaming and a little bit less of bandwidth for Facebook and so on. So it is a good thing having NVAR. Then we evolved into the new, more recent versions of wireless LAN controllers, which are the Catalyst 9800. And with these, we can have quality of service here in the wireless world, as well as quality of service in the wired world. With all wireless LAN controllers, we only could guarantee quality of service here in the wired world. But with the new recent wireless LAN controllers, we can enable something that is known as enhanced distributed channel access, which is a Wi-Fi extension, in order to provide something that is known as user priority over the air. So we can actually mark packets that are traveling over the air in order to provide quality of service over the air. And NVAR evolved into something that is known as AVC now, which is known as application visibility and control. So that will be the quality of service evolution for wireless. remember that many features that are quality of service features have evolved also as years go by. For instance, when talking about policing, in your first switches, you could only set up ingress policing in all switches. So if you had your switch, you could only policy here in the ingress. You could not do policy in the egress. It was not possible. And if for all switches, policing was used also for marking. And then we evolved into having this feature release for ingress and egress traffic. We had single rate and double rate policing. Some commands have stayed over the years and they mean the same. That is one of the questions that many network administrators have. Why can I set up policy using zero? Why can I set up policy using rate? These are commands that are left behind by old technologies and still exist in the current operating systems. And then policing, we had the classic policing, class-based policing, which is what we usually use. But Cisco also have something that is known microflow policing in some switches and aggregated policing. Let's review an example of the configuration and how it has evolved over the years. This is a classic MLS QoS WRR configuration settings. For instance, for a Catalyst 6500, this is the way that you will configure random early detection for your egress queuing in a Catalyst 600 device using MLS QoS WRR commands. And this is a way of doing weighted trail drop in the ingress queues of Catalyst 6500 if you had a supervisor 720. In this case, your command will be MLS QoS receive. Now, this evolved into the series of switches that will use sharing and shaping route robin. For instance, the Catalyst 3750. In this case, we are configuring weighted tail drop in the ingress queues. Remember that we only have two queues in these types of switches, Q1 and Q2. And we had 4 queues in the egress. So this is the configuration that does weighted tail drop for the egress queues. Notice that we can configure Q1, 2, 3, and 4. So notice that these commands are MLS, QoS, SRR. Opposite to the previous generation of switches that will use MLS, QoS, WRR. And then the most recent switches will use modular quality of service CLI that is based on blocks. So you create your ACL block to identify some type of traffic, and then you will use these blocks to create your class map blocks. Then when you build these class map blocks, you can create your policy map block that references one of several class maps, and these several class maps will reference one or many ACLs, and then you can apply this policy map into an interface of your switch for ingress traffic or for egress traffic. Okay, in the next session, we're going to talk about the quality of service components. And then in following sessions, we're going to actually see how to interpret configurations for each quality of service component. That's it.